Usually the robots, mobile robots, manipulators, the robots which you can see even here, they are fixed shape, which means that you cannot change how the robot looks like. I mean from physical point of view, from topology. So for example, if you have a mobile robot, it has several wheels, the distance between the wheels is still the same. You cannot change it. And if such a robot is in a difficult environment, for example here on Mars, or here this is a military robot operating in some restricted area, it can do a lot of things, but if you want the robot, for example this robot, to handle some things, it cannot do it because it doesn't have a manipulator. And this is big disadvantage in certain situation. So the idea is to have something which is more flexible, and the inspiration was taken from nature, where living creatures are made from a lot of small units, from cells. They are connected together in some way, and they are cooperating to make large organisms, and this is called modular robotics. So the idea is that we have a lot of small modules like here. The modules are connected together. Each module can do a lot of things like move, they can sense, they have a lot of sensors. There is also some processing units, some small computer. There are also some actuators. So for example, this guy, it can move the hands because somewhere here there are some motors. The small modules also have communication units. They can have Wi-Fi or Zigbee or Bluetooth or Ethernet even in some cases. And you can make a lot of things out of the same modules, so you can use them to make a snake. The snake is quite good on, for example, on this environment, snake can wave here and it's okay. But in more rough terrain, it's maybe better to walk. So you can connect the same modules, the same number of modules to something like dog, or to create a humanoid. Oh, sorry. Yeah. This is some example how it can be useful. So, for example, if you want to send some spaceship to space, and we need to do a lot of things up there. So, for example, if you want to spread out the solar panels, we need some manipulators. But it's not a good idea to send also two manipulators just to do this specific task, like this manipulator and this one. But the better thing is that we can send a bunch of modules. The modules will connect together and make the manipulators work using this construction to certain points, manipulate with the solar panels, and they can, I don't know what, go here, make another manipulators, hold some antenna, or what is it, or here it's written here that they are doing welding, so it's quite flexible. I will show you a video from a project that we did last 4 years. It was a European project. This is a stop motion video, this is not reality. So we have a swarm of modules here behind, and the modules can do a lot of useful things, like they can walk here around and they can explore. They can together build a map of this environment, and later they can decide that they want to escape from this room or from this building somewhere else. But they can do it separately. They need to cooperate to make this large organism which can walk in difficult terrain. And also these robots can cooperate with other guys, so there will be helicopter and mobile robots. Finally, they can reach the target region, which is below the floor, and they can find, I don't know what, something there. Okay, so this motivation. But it's very, very hard to achieve such kind of system. There are technical problems and also, let's say, algorithm problems or scientific problems. First, it's quite hard to make robust modules which are able to connect in different ways, which are able, let's say, the docking mechanism which holds the modules must be very solid. It must hold a lot of weights to be able to make a manipulator, for example. In the same way, it has to provide some kind of power bus, a communication bus. You must decide from energy point of view, like we have in that project, there are a lot of electrical engineers who decided how to make a system with low energy consumption, or a system where if one module, like this one doesn't have energy, so it can share the energy from other modules. It's not so easy task. There are also scientific problems which are more interesting for scientists, which is, for example, reconfiguration planning, which is how to find actions for the modules to change the structure of the robot. So, for example, here, what the individual modules has to do to change from this guy to this guy. It's a very complex task because there's many modules. Each module can connect to different position. You have different places where the robots can be put on. So it's many combinations, and you need to find some combination which is good, which is feasible, which doesn't cost so much energy, and so on. Also, a very interesting question is how to find shape for a robot. So, for example, guys in art or artists, they are able to draw some shape of a robot, like they will have 6 legs or 7 legs. But from algorithmic point of view, it's not so easy to find it. What kind of shape we have to use in what kind of environment. Then if we have a shape, we need to move that robot. So we need to solve motion planning, so how to control the motors to go somewhere with the robot. Also, we need to solve problems here if the robots are not connected together, so how they have to communicate with each other, how the modules have to know that this is his neighbor and that this neighbor can be useful for something, to connect together, for example. So there are many possibilities, and all these scientific challenges are solved during the last 20 years maybe, and still there are a lot of problems that need to be worked on. I pick up one of them, which is locomotion control. The task is how to move the robot. So, for example, we have a snake here. The snake has 3 modules. Each module has 1 motor. So basically, we need to control 3 motors to wave the snake to go somewhere. You can find a lot of methods how to do that. You can do it by hand. It's easy. If you put some sinus waves to each motor, it will work. But the question is, what if we add another module to the snake? So what if we will have 4 snake module? Should we use the same algorithm? Should we use a different one? So this is something which is solved. I hope I will show snake here. So this is example of how such a robot can walk. Of course, if you want to find some good motion pattern, I mean the waving, we need to measure it. So we use normal meter for it. So it's one example. What's there? Okay. So if you know how to wave a snake, then you can go for complex organisms like 4-legged module. It's obvious that we need to do something different. So what we did this summer, try to control this one. It's several hours just to test the control signals, which were developed using physical simulator before that. There are still other problems. For example, if you want to find some motion pattern, how to walk with the robot, you need to maintain stability of the robot, which is not so easy. So we can see this is not stable locomotion, it's very slow. Okay. And last, what we did, the largest organism, 6-legged robot with 25 modules. This was programmed by hand, no clever algorithm. By the way, consumption of this robot is 570 watts. So that's why we have the cables here. But theoretically, each robot has a battery here, so theoretically it should walk on batteries, but we didn't test it. And the speed of motion is 70 centimeters per 5 minutes, so it's quite good. Okay. Yeah, I saw this. Now I will show you how we learned how to walk with some kind of robot. So we have this small cross robot, and we tried to learn it how to walk to left, right, forward and back. And for this we used some kind of optimization. It's called PSO, if you know somebody of you. It's some kind of algorithm. And so we try to apply different signals to the motors. So the robot did something. We need to track the robot in the arena, so that's why we use this circle tag. On the top of the arena there was a camera. We tracked the robot, and based on the speed of the robot we decided if these signals are good or not. This is end of evolution, so it was after 2 weeks of playing with the robot. The robot was able to walk quite smooth. So you can see 4 motion patterns, left, right, and so on. And later we try to investigate if these patterns can be used for larger ones. This one. So we use the same pattern for we add modules to each leg. So this guy has 9 modules, and is also able to walk. Okay. And now if you are able to walk in four directions, you can use it in some clever algorithm. Like here, you have robot in an environment, you have obstacles here, red circles, and you want to go here to that yellow circle. You can create a plan for the robot, which is this red path, and the robot can go there to that position. So now the robot is doing something useful. And of course, yeah, you can do it with different. Yeah, we tested in many scenarios. Okay, so that's all.